Okay, it looks like we're live. So welcome back. Today I'm going to be continuing to work on KanoScript. Alright, so yeah, that's an example of that. Let's see. So last stream, we got to say we can allocate memory, and we can also write to the memory. We technically have a way to read from it, but it's not very good thus far. So I'll sort of show what it looks like, right? So I was working on this example before the stream. Yeah, so we can allocate space for it. So in this case, we're allocating 2. This is bytes, right? We're allocating 2 bytes. Works the same way as malloc in C, essentially. Yeah, and then we can store at the pointer location. We can store whatever value you want here, and then this is the number of bytes to write to it, right? So in this case, 1. So it would be like basically a uint 8, right? That kind of thing. And then here, in order to store at the next location of it, we can cast it to a void pointer and do x plus 1, right? So this gets casted to a void pointer. And then we wrap it in. Well, I guess we don't really have to do that, so we can get rid of that. And then 26, right? We're writing at the next one. So this is like an uint 8 array, right? That kind of thing. And then now this is a bit interesting. So we can exit with x0, and then I'll show sort of what that looks like. If I run that, I missed. All right, yeah, this has to be wrapped. I forgot. Because of the way that it works, we have to do that. All right, so we do that, and then echo 25, right? 25. That is correct. We can do 1. It does not work, and I'll talk about why in a second. So it exits with 32. That's obviously not right. So if we actually modify the assembly and change this to 1, this is the size of whatever the elements are. Size of element, right? And then I manually recompile it and run it. And then there we go. That's actually the right one. Okay. Yes, the reason this happens is because this pointer is 8 bytes, right? The size of it. So when we try to do this, we exit with that. And it's trying to read 8 bytes. It thinks it's a pointer array. So the way to get around this would be, there's basically 2 ways, which both of them will be implemented eventually. I'm going to go with the simpler one today. So first, we could do something like this, right? We could have a U8 pointer, and that's the array, U8 pointer. And then we read from that, and then we just, we know the type there. Well, I guess that wouldn't, like, that'd be, like, there's a bit more stuff we have to implement for that. Or we can keep it like this. We can implement a read instruction, right? So read x1, 1 byte from it. And that would read the first one, or x, plus 1 to repeat that whole thing, 1 byte from that, and that'd be the next one. We can also, since we don't really have type checking right now, we could do this, and I'm pretty sure that will work as well. Yes, that does work. Because a character is 1 byte. But we do waste, like, space on the stack and such like that. Because the stack is basically a C union. So it allocates space for the largest element in there. So we can have characters and U8s on there, but it's still going to use up the 8 bytes. So it's kind of a waste, unless you're storing it in the memory, Because the memory, it actually is allocating the proper amount, if that makes any sense. So you're basically wasting memory if you use the stack to store them. Like, when you're using them, you have to move it to the stack. But otherwise, it doesn't need to be stored on the stack. It can be stored in the memory, and then you're not wasting space. Yeah, but we can use this, and then we can do stuff with it, So we could allocate 3 bytes here. Do this, and we can store 128 here. And then still 1, and then we do this, and that, we run that, echo, 128, that's correct. We can't go over, what is it, 256, that is the max. So if we do that, actually exit already breaks, okay? Because I'm pretty sure exit expects a relink, right? So that's like the max, 255. Yeah. So that's sort of the thing. It's a U8, but we could, that's really all that we can do. Because we don't have, like, 16-bit data type or 32-bit or anything like that right now. We have 64-bit, integers, floats, and pointers. And then we have 1 byte characters, 8 bits, right? That's all that we have at the moment for the data types. Yeah, so the thing with U8, right, or U16, or U32, or anything less than 64, anything less than 64 bits, it's probably going to be stored in the memory unless you're using it. Because it needs to be represented, like I was saying before, as one of those larger types when it's on the stack. Okay. So that's sort of the idea here. What I would like to implement today is read, right? So this is sort of what I was getting at. Read from the pointer, the number of bytes, and then that's going to read that and you can store that in a value. So y int equals read. Yeah, so I'm not going to implement, U8 yet or whatever, but it would basically be moving that to an integer, a 64-bit integer, if that makes any sense. Let's see. I'm not sure exactly how to pronounce your name. So I do apologize for that, but you just followed. Thank you. Yeah, I'm not exactly sure. Sorry about that. But this is the idea. This is the idea, if that makes any sense. So, that's what I'd like to do, is implement this read instruction. And it probably look like this. Like you write parentheses around it to make sure it's not ambiguous or anything like that. Let's see. So that shouldn't be too hard to do. We have the foundation for it. And the read, well, actually it's probably going to be called get. Because read, that might be stored for stuff with files, right? So yeah, I think I'll call it get instead. I think that, that works. I might change it to still in the future, but that is the idea. So, let's get started. Enough talking. Let's see. So in the front end, we don't need any more data types because, like I said, we're not doing that yet. We do need some more token types. No, we don't. No, we do not. We need built-in stuff. Because it's just one data type, but then there's different ones for it. So here are the ones that we have here. So I can make another one of these, and we can have get. That's going to be 3. Built-in get. So I do need to add the built-in. Yeah. And that's gonna basically I'll show how it works on the stack and such. Right. I'll show what the compiled assembly looks like. Yes, but that's not the idea. And let's see. Is there another built-in thing here? Yeah, we do have to consider things here. So the read does not return a pointer, and instead returns. I guess okay. It's going to return a different data type depending on certain things. It is always going to be 64-bit though, so I think I'm going to say it's a pointer, at least for now. But I will need to update this so that it's more based on what is actually what, like what is what. Because Alec, it's always going to return a pointer. And then you can pass that to whatever you want. And then 2VP as well, that's always going to return a pointer. Hello, Stan. Very original message. Okay. We have that. Okay. Then was there another place? I think that was it. Okay, yeah, so we're good there. So now I need to add the built-in type. So we'll have built-in right down here, so it's the correct order. Built-in get. Okay. And let's see, I don't think there's another built-in thing here that we have to change. So now it's just in the backend. So we should be able to parse it now. We can lex and parse that, but now we need to generate it, right? Within expression. Let's actually search for built-in. So all of these do different things. So it's going to be similar to the store one. Okay. Telescope-like feature. Yeah. It's pretty nice. It was implemented by Tim. Tim, here I can go to Hano. Yes. It's really more similar to if you open Vim on a directory. So actually, here, I'll put it here. That's not right. Okay, how do I, press the wrong button? Alright, there we go. If you open Vim on the directory, it opens like this. It's kind of more like that than Telescope. But I basically use it like Telescope, so, yeah, and it's actually more helpful, because I didn't really use that feature in Vim. I said use Telescope. But yeah, I do like it. I can show, just to make sure, proper credit and such. Let's see, I gotta go back, it's a little bit. Yeah, right here. So this was the original pull request. So yes, I didn't actually work on it at all, so that's pretty cool. But yeah, I use it a lot. Okay. So the count is going to be 2, because we have the pointer and then the number of bytes. So generate the expressions. This is actually not stored, it is get. Not working on it all, and having it working is double. Yes, indeed. Yes, indeed. Okay. It needs to be, let's see. So it's pushing something onto the stack, so it's going to be -1. Yeah. I should have said you're influencing yourself. Well, that won't be very obvious. Is it called read? the instruction. I think so. Yeah, read. Okay. That's what we're looking for. So read, and that should be pretty much it. So now that should work, and it should return the proper value. I build that, and let's see. So to get case by, yeah, I forgot to change the name to get. Source, trust me, bro. Yeah. Don't look at the Git history. Built-in read undeclared. What? What? Oh yeah. Where did I put that? Because it's called get. Okay. Make, and there we go. So it compiles, and let's take a look. So I did this. Yes, that should pretty much work. If we exit with y, 25, okay. And then if I change this to I have to do a lot of parentheses here, but that's okay. X plus 1, it should be, or let's do plus 2, it should be 255. And I forgot the closing. Okay. 50 pointer. Okay, it did not work. Because I did not cast it to avoid one. How do people even contribute to the code that has no comments? I don't know. I don't, like, sometimes comments are helpful, but for me, it kind of adds noise and makes it even harder to read, if I'm being honest. Like, certain ones are helpful, but, you know, finishing your evolution project, can I send a zoom? Nice, nice. Very excited for that. 98, did not work. What the heck? I did plus 12. Oh, that's not ready. So how'd that go? How difficult was it? That's not right. 255, there we go. It did actually work, so that is very cool. And if I do this, it should be at 26. There we go. Alright. Yeah, we should be able to put that here as well. So like get GDP plus x plus 1, 1. And then get rid of that in time. Okay, actually I might have to yeah. No? Okay, 5. Right here. What? If I head off and people make comments, assigning variable initialize earlier 42 in yeah. Yeah, comments just add comments. I think it's because like at least in my experience, right? So I'm in college right now, and a lot of the time they say to document your programs with comments, right? And it says to do stuff like that, you know. So I think that's why a lot of people do that. But I've been programming for years, like before I started college, so I got used to not writing very many comments unless it's, you know, absolutely needed. Before I got to this point. But if you're starting out, like you're pretty new, then I could see how that habit would develop, you know? And I think comments like that make it harder to read code in general, because you're used to having a comment that shows exactly what's happening, even if it's something intuitive. You know, it can be harder, like, for your actual skill of reading code if you always write code like that. An angry teacher will tell them off for not adding comments. Yeah. Yeah, exactly. Alright, why does that not work? Did I... Oh. Okay, 5, 6. Where is 6? Right here. Okay, why does it say it found closed? That is not right. This must be in the wrong order, currently. Yeah, I think I forgot to add something here. That is causing that. So that's probably from the built-in, actually. Built-in types. If I go to that, where is that? Front end here. Built-in, yeah, so it goes after exit, and I didn't add that, so that threw the whole thing off. Okay, and now if I run it, it's going to give a better message. Okay, but found that. Okay, so then that is in the... Ooh, you know what that is? It's the way that we're parsing exit, right? So native exit as like a statement. Coders always tell you off for having files with 800 lines and without any comments. Then I spend an hour and split it all out. Yeah. Yeah. I kind of like big files. Having it all there, you know, not having to jump between files. Yeah, I mean, 800 lines, that's not even that much, you know? Like, even when I split mine out, Like a lot of my files, like this one has 820 lines, and I have quite a few files. You know, like I don't really get not liking that because you can just search for what you're looking for. You know, like maybe when you're first looking at it, it might be a bit more intimidating. But even for me, like it's more intimidating coming to something and there's 10,000 files they have to go through. So like you can see all the definitions in just a handful of files. You know. So this, I did not add the stuff for. I don't really need it because we parsed the expression, so this isn't needed at all. Because yeah, we checked for that in the parse expression, so this doesn't matter. That was whoops, that was not needed. Variable token 586. We don't actually use that. So let's get rid of it. I don't want to get rid of it entirely. Just make sure it's right. I don't need to use it. And there we go, 26. Okay. That is correct. Let's make sure. Alright, yeah, so now we can actually read from it. So that's nice. We can store and read. So yeah, I'll add more types so that you can access it more like arrays. Like you could have x u16, right, equals alec u16 either pointer or array, something like that. Alec 16 or whatever. So then 16. Well, let's make it. Well, Alec 32, right? Something like that. Keshev followed. Thank you. Appreciate that. Okay, so you can do something like that. But you can't do that now because these types don't exist. But yeah, then you can do something like that and be an array for them, and then you can access it more properly. Because this way, it's kind of verbose, right? But for now, that's fine. That's fine. And actually, if I wanted to, I could just implement it in the language, you know, like where you call a function to get it. But I'm not sure how that would look. That probably wouldn't look very good syntactically. So I'll probably add the array syntax for this. What's up? What's up? Okay. Okay. And okay. So let's see what else. Yeah, so I can give it this. That's not needed. Okay, calling arts are. And what else? This type check. I'm not actually even using it because it kind of broke stuff. So I need to implement that in the future, like more type check. Like in the variable declarations, we need to check that. And all expressions kind of need to be given a value, if that makes any sense. Right. So like based on the leftmost thing, I think makes the most sense. So like if you're calling a function, then it'd be the return value of that function. Or if you're calling a built-in, it'd be the return value of the built-in. Or if it's just a value, it's the value of the value. Value of the value. What's your name? Deep lore. Very complex lore. Funny bug a few days ago, I had a vector of indexes to delete from vector, just iterated over those indexes and deleted each index, but then you encountered a bug that the indexes obviously shifted as you deleted them. So eventually went out of bounds. Didn't realize it for now. That is fun. I'm pretty sure I've had like pretty much the same thing happen before to me. Yeah, that's pretty funny though. Yeah, and it's something that like you don't think about, but then once you realize what's happening, it's like, why didn't I realize that, you know? Those are pretty funny bugs. I like those bugs. Not dealing with them, but regardless. Okay. So yeah, we can use this like can technically use it like structs now as well. So like you can allocate space. So say you wanted yeah, you wanted this, and you want it to be, I guess since we don't really have a good way of working the floats or anything, I can't show that explicitly. But like you could make it a struct basically, right? So you could have 16 where one part you allocate right an integer value. And you have to call that each time, obviously, each time you want that. But this is sort of how structs will work under the hood, right? You will store 2 AP. Well, you don't have to just store at the first one. Whatever you're in drag, so 82. 8, right? So that's like size of in 64. You can store X. You have to do this whole thing. AP X plus 1. You can store your float value, so that, right? That's 8 as well. And you can store that there, and you can actually decode. Yeah, that, and yeah, we can't really exit with that, and we don't have where to print it. We can print integers, but we can't print, like, I could implement that, I just haven't implemented the printing of integers. Hashmark for the indexes keys to be fixed. Okay. Thought a better way to do that than a hash map, because that seems like it might be wasteful. Though. But yeah, whatever works. Can use a hashtag delete not by index. Okay. Okay. Yeah, so I want to do just X and read 8. Read 1. Let's actually exit with. Yeah, I still exit it exit place, so that makes sense. But if it's a greater value, it's not going to work. So like I can say that's greater than 86. Yeah, we don't have support for negative numbers, but the funny thing is on the stack, it's stored as an assigned integer. So we are limited by that, but we can't actually use that at the moment. Context was telling you use a hash map was suitable. Oh, okay, okay. I see. Makes sense. Yeah, so that like overflows because exit expects a U8. How do you implement undo and redo? Basically, the way it works is every action has an associated command. So like if you would insert a couple of characters, then that is basically a command, right? So that is insert characters. Then what it will do is push onto the undo stack the opposite of the action. So we'll push delete characters here to there, things like that. I did do the thing where you store the whole thing every time as the start to get an idea how it would work, and that obviously caused a lot of problems, as you could imagine. Yeah, the way it works now, it basically has commands. It's similar to Nano, how Nano has it, where each action has a command, and then an opposite of that. So then it gets pushed onto the undo stack, and then if you undo it, it gets pushed on the redo stack as well, the opposite, back and forth. Yeah, rip memory, yes. Yeah, so that's basically how it works. It's not perfect. Like certain things you can break. Like that works fine. But sometimes I've had some issues with the brace because of how they work. But yeah, it works pretty well. Like good enough, Like this, selecting text and pressing X, it will push onto the undo stack the opposite of that, which is delete, or which is insert those text. And then it has to save the text obviously to put them back. But just the text that you delete. Yeah, that's basically how it works. Yeah, so this can't store more than that. But we can print it out. So if I get this here, I just yank it and move it over here. That's the wrong one. Nope, that's the wrong one too. That's the okay. This one. Put it up here. Let's see that here. Okay. Good solution. Yeah, yeah. I was reading through the way it works in like other popular text editors, BIM, Nano and stuff, and Nano, it seemed the most intuitive, and also made the most sense. Like the other ones were kind of confusing, and like they obviously probably are better, like with tree structures and such. Yeah. So you like go back and then you enter to a different branch of the tree. So maybe more powerful, but maybe not completely necessary. I'll just store actions from an enum and have an opposite for each action, some sort of match. Yeah, that's pretty much exactly how it works. Yeah. Okay, so if I print int, and let's see if this will work. So if I get Let's have that. So why is that? Is this trying to print X? Do I need to wrap it again? What? That's not good. An assertion fail. I don't know why that happened. Something to do with this though. Need to take a look at that. Cursor went out of bounds and then it failed. Probably shouldn't assert with that. But that is a problem. And now this is not right. Okay, so that doesn't work. That does. Wait, what? Oh, you know what? It's gonna be +1 here, not +8. Yeah, okay. There we go. Have to echo the X code. Joy matches and enums and Rust. Yeah, they're pretty nice. Rust has some good features. Yeah, I mean, I like a lot of things about Rust, but then other things, I don't know, it's just annoying to use. Also, I'm not like super great at it. I don't have a lot of practice, but from what I've used it from it, like, it has some good things, but also I feel like it has a similar problem to C++, where they just keep adding new features. You know, like same way to do. You can do the same thing like 500 different ways. Is what I'm trying to say. The borrow checker. I mean, I get it. You're right. It's good in a lot of ways, but also is a lot of bad. You know. But again, I haven't used it enough to say for sure like my exact opinion. I'll try to print out this. This will print out this, but in integer form. So what's that going to look like? Yeah, looks like that. That makes sense. Yeah, so I don't have a function to print floats at the moment, and I don't know that I want to implement it right now. So I'm not going to do that, but let's see, can we store, we could store pointers there as well. So if I allocate, I'll do it up here. I allocate a string, text, right? That's going to be a pointer to the string in a similar way that C works. Yeah, so then I could store that here, like pointer to it. And then if I try to write that, right, get +8, then I have to do this whole thing. See, it had me get, so it's something with, yeah, so something like this. Yeah, okay, okay, I think I can, oh, no, that still doesn't work. Let's see, get, yeah, okay, it's something new with those. Most thing about the borrow checker is that if you're iterating and therefore borrowing throughout the whole iterator a specific iterable variable, you can't mutate it during the iterator. Yeah. So that things do during the loop in an array and do them afterwards. Okay. I see. Is that the standard way of doing things, or is it kind of like a workaround? Yeah, I haven't used Rust in a while now. That's that. Okay, write that there. Then I'm gonna save it now, and I want to try to write that. So write get get x +8. That's not x. 8 by 5, and try to write that. And I might have to cast that whole thing to a void pointer as well. Googling it up, everyone said you just had to restructure your code, and there was no universal workaround. Okay, I see. Right. Record string. Wait, what? Happen again. Alright, has to do with these. Oh, what is that about? Let's see. Doesn't happen there, but if I do this, it moves the cursor out of bounds. Okay, well, I found out how to replicate it, so every Rust developer has their own workarounds. I use that one. Rest of the language that requires you to restructure code to fix a bug. It's you, not the language. Yeah, that is the thing with Rust. Which I do see the appeal of that. Like, sort of, well, not necessarily that specific thing, but like basically a lot of the things with Rust. That specific thing could have an appeal, but you know what I'm saying. Oh, you know what? Extra. Why did it say that? Wait, is that? Let's say string. Oh shoot. Actually, is it native right in there? Parts. Where do I say that? Clippy is W. What is Clippy? Clippy. Bro. Yeah, I don't really use Rust. Bunch of links to cat. Oh, okay, I see. Okay. Yeah, I think I've heard of this, but I haven't used it. Mm, so it's like a linter. Real-time tips from Human Food. Oh, that's nice. That's nice. Okay. Yeah. Well, I will probably start it so I can basically bookmark it. Right. Yeah, I have it not. I've not used that before. Shows you how to classify your code by line. Oh, okay. Nice. That's good. Like I like when a language has external tools that help you, learn the language and make it better, right? It is an AI. Okay, that's good. Just imagine it's just ChatGPT on the back end. That'd be fun. Oh, okay, this is why. So maybe I don't even need a case for that. Yeah, I don't really need that. Whoops, now I just broke stuff. Okay. Yes, I really don't need it anymore. It's from the old system. I can get rid of it. Let's call it Clippy. No one will notice. Yeah, like the Windows thing, right? That was called Clippy also. Oh, that's not a reference to. But yeah, it was called Clippy, right? Yeah, that's what I think of when I see Clippy. That's unused now. Oh, probably. That wasn't very clear what it was doing anyway. I don't know what I called it. And also in the header file. We'll ChatGPT in Windows and call something else. Nobody will notice. Yeah. The original ChatGPT. Nice. Did I need this? Okay, there we go. Now, big string. Alright, still says that. Why does it still say that? Mm, what's and in C? Basically, let's see. I have an example. When you have something that's not a pointer. Let's see. Actually, I have it down here. So here, I declare. What do I do that? Yeah, right now, here, root up here, it is not a pointer, right? It is something allocated on the stack. When you pass it to a function that expects a pointer, you can basically, like you take the pointer to it, right? A reference to it. You pass the reference to it rather than the object itself. So it's like similar to how it's used in C, or not in C, in Rust. It has to do with pointer, but it's used in a different context. And then to dereference, or to declare a pointer, you would use the star. And use reference well in Rust, yeah. And then the star in Rust is used for dereferencing, right? Like only dereferencing, right? If I remember correctly. That's true. Yeah, okay. I don't have anything like that. Let me go to that. Yeah, so it's not calling that. C and Rust are those language coding in which, okay, are those language coding in which is a skill on its own. Okay. Yeah. Yeah, well, I think Rust especially. Like C, you can kind of use at least a little bit. Like maybe not stuff with memory and such. Like that might be confusing. Like it's sort of like easy if you're coming from another language. Whereas Rust, it's like a lot different. Like you could probably do some stuff, but do anything more than the most simple stuff, you have to have a good understanding of a lot of stuff, like the borrow checker and stuff like that. I think it's true. I have that. Expected. Oh shoot, nice. I think that last one was. Maybe not. Yeah, it's not because it has those. So let's keep going. Expected. Yeah, the rest I put token. So maybe design. I could actually look in GDB. That might help. Okay, let's see where it fails at. Very strange. Alright, it didn't show me. So we'll break on parts. Let's go there. Alright, we'll just step through until we get to where it fails. Continue. Right here. Token peak. Is that where it failed, or is that something else? Yeah, okay, it wasn't here. I hate those Rust extras on YouTube which show a very simple example of how the borrow checker works, and then forget that when a part is big, it stops being simple. Yeah. Hard part about the borrow checker is that it gets insane as the project goes. Yeah. Yeah. Yeah, I haven't had like a large project in Rust. Like the largest one I have was either the fourth interpreter or the Twitch bot. Well, Twitch bot is not even that big, so I don't like have experience with that. But a paper was pretty simple. Yeah, it seems simple, but it's really complex, right? Actually, it could be. No, it's not that. All right, let me start that again. I'll just keep going through. Setting your project up for easier development in the future. Right. Whereas you'll have to restructure. That's probably like one of my least favorite parts. Like refactoring is fine, but when you have to restructure the whole thing, that's pretty annoying. Sometimes it's worth it. Okay. So it wasn't even in there. It was after that. Okay, so I'm actually looking in the wrong place. It's in the back end. Expected script. Do I have something like that? Here, okay. Oh, I see. Anyway, there's none of those. And type is not equal extra a built-in. It could be that. That is what we are using. There we go. And then it did actually work. Alright, yes, we stored it. Stored it in the structure essentially. So that is cool. The string, right? So we took basically what happened. So we allocated here. It's just a character, but that this part doesn't matter. It's really pointer. Yeah, we allocate a pointer. 16 bytes. So that'd be two 8-byte data. What's it called? Yeah, values, right? Whatever. Then we allocate a string, which basically is a pointer to the beginning of the string, like a character array. Same way as C. This is just a function, don't worry about that. And we store at the pointer a 64-bit integer here. Really, it doesn't have to be 64-bit, but we store it as though it was. And then at the next part of it, we store the pointer to the beginning of the string, and then we can write that, retrieve the value. Yeah, so we can store any value that we want in here, and it's similar to a struct, right? The struct syntax, which is gonna be very simple. I don't know. Do I want it to look like this? Struct and then name. It's gonna script fast. I haven't really tested the speed, so I don't know exactly. It's probably not like too fast. Um, right. So it has like certain things with the memory probably going to be a little slow because of the way it's implemented. But other than that, the rest of it shouldn't be like it should be decent. I don't know. I'll make a test once I implement just a few more features, like some sort of test, like maybe would be good. Something that has to refresh fast. So maybe like a terminal game or something like that, so you could sort of see how it looks, or something more specific like a iterating over an array and changing it, right? So maybe a sorting function that could be interesting. Yeah, something like that. I'll implement some sort of test and then actually test speed, compare it to C, probably Lua and Python, right? Python is like that. Yeah, maybe compare it to some of those. Pretty soon, like it's getting there. But yeah, other than that, I haven't really tested the speed. Like to contribute, but there will be a future way for me to do that with Rust. Maybe I can make an installer. Ooh, okay. Let me think. So, installer. Um, well, let's see. CLI for the installer. Yeah, yeah, that could be useful. Mm, like if it was cross-platform installer, right, where it sort of checks the like I don't know how hard this would be doing Rust, but where it checks the current platform and then installs the correct things and like updates it or whatever. Something like that could be interesting. I don't know. I'll have to think a different Rust thing. Let's see. So I do want. Well, let's see. So something else could be interesting. Maybe I'm not sure like what you think about this, but maybe something to compile either to the bytecode of the virtual machine to something else, or a different thing, like maybe like compiling the bytecode of the virtual machine. That's what it compiles to. Um, to say WASM or something like that, or the other way around, which would be more complicated, probably the other way around, but something like that, so compiling like that could be written in another language as well. But that's a larger task because you have to know a lot of different things for that. We have Kano itself, Kano script. Why not make a CLI for Kano like Rust app? Okay, okay, I like that. Use it for updating and doing stuff like that. I might go with a different name than Kano up, but the same idea. Yeah, that could be cool. That would actually probably be really useful. Yeah, I like that. I like that idea. Like it for sure. Okay. Maybe you can make nightly and stable version so we can Kano up switch nightly. Yeah, yeah. Yeah, probably would have that, like eventually. Because obviously you don't want breaking changes in the stable release. Struct what? Sure, say that. Drinker. How do I want it like that? Probably like that. Maybe something like that. And then what else? So then X. One utility for looking after the whole of Kano on your machine. Yeah, that'd be cool. It's like for Kano script, for Kano text editor, and any other addition to the Kano ecosystem. That'd be cool. That'd be pretty cool. Okay. So I'm thinking, do I want structs to look like this, or like that doesn't really make as much sense because that's really for blocks, but also yeah, I don't know, like that. I think that's better. Yeah. Like that. That looks better, I think. Okay. Yeah, so that's what it would look like. Similar to tables, how tables look in Lua. It's sort of similar to that, or well, I guess it really just looks like C structs, right? So this would be even unequal because why use colon? Well, no, because it's the type. So that's why use colon. Okay, actually that makes sense. Yeah, so this is like declaring it like this. And I don't know if I want default values in there, but then when you declare one, you're gonna have to do that. So view equals something like that. Yeah. Well, x equals. So this isn't equals that. Yeah, I think that would work. I think that makes sense. Right. Is there anything else? Anything else for this? Yeah, I think like that syntax is fine. Like that's pretty much how the syntax works in most languages for structs. At least C-like languages. So I think that is good. It's like a string kind of thing. Just as an example. So basically what this will do is the same thing that we do here. We'll allocate 16 bytes whenever you declare it. Then it will set these as the fields in this kind of way. Implement updating like this. When you know Kano is ready for an actual update, you just go into releases on GitHub, and Kano up just fetches it from there. There's a lot more to do for Kano, or whatever we call it. Okay. I'll probably add like a, whoops, that's not what I want. Like a, an issue for this, just to keep track of some ideas and such. I'll make just on here. It's like Kano progress. Later, installer, later, and overall system. Yeah. So I'll like add comments there as I think of things. Okay. Yeah, I think that'd be really cool. That's interesting. Alright, so that's how that would look. Yeah, basically we just do the same things that we do here. So that is fine. The only thing that's gonna be interesting to implement, that when you smash a logo of Rust and say part of your app is made in Rust, you get 20% more users. Okay, that's true. That is definitely true. I don't really care about that though, but yes. Like I'd rather I care more about like I'm making it for me to use. Made in Rust, by the way. Yeah. Made in Rust, by the way, using Arch, by the way. But yeah. I care more about if it works good for me to use it, because that is what I'm making for to use. So yeah, you just advertise it as made in Rust, by the way, but the only thing that's actually made in Rust is the command line installer and stuff. That's kind of fun. Yeah, so the thing with this is like you have to store this as you're parsing, right? So you need to lex it all. You have to parse it. So this, like when you're lexing, you don't know that this is a data type yet. But then when you go through and parse, it gets added to the list of structs. So when you're looking here, you'll know during the parsing, but not during the lexing. So that's interesting. Main Rust and C. Who cares about the order? Rust, yeah, and C. Just in like the footnote. Don't tell the U.S. government, right? I'll go to jail. Okay. Right, so I'm not working on that now, but that is the idea, and it's gonna, like, basically you can do that now. It's just, you have to do a lot more work. Huh? Oh, not actually. Like when they officially endorsed like Rust and languages like that, and said you should stay away from using C and C++. So people made memes about it being illegal and stuff using C. That was a while ago though, but it's still fun. It's only a joke. Yeah. Well, they did say not to use C and C++, but it's not that it's actually illegal to use. And like they're gonna be moving away from it for like government services. in using safe languages, right? Like Ada and Rust. Also, I think it's in JavaScript or whatever. So yeah. Yeah. Okay. So what is this? Yeah, expected string. That's not really. That's kind of outdated. Do I need to even have this at all? Because it still could fail. Avoid C and C++. Yeah. 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 Because of memory issues mostly. Okay, so do I even want this? Like, it's useful at the time, but now I'm not sure it's like I need better type checking. But this is that's not exactly helpful because what is this? Expression. What is that? Okay, I don't remember this, but I will read that. Oh, but yeah, that one was at the right one because we can use pointers and such. I don't think they probably won't ban them. Like especially since a lot of the other languages, like other language that they endorsed are either like they're written in C or C++, interpreted by C or C++. Like I think they said Java, right? The JVM is written in C, if I'm not mistaken. JVM, so to speak. Like they said, Java was one of them, specifically OpenJDK. Let's see, is that the right one? How do you find it? That's Java. I know that the compiler is written in Java, right? I think just talking. Yeah, I think I'm just saying like discouraging using it. JVM.h is it? Yeah, so like it's C and C++. Yeah, and also a lot of the things they use in other languages calls to C and C++ code as well. Like Python, pretty much all of that is just C++ code and C, right? Yeah, so if they banned C entirely, you'd have to start over, basically. I think the idea is just to discourage the use of it for new things, and instead encourage using safer languages. Month-long session, everybody will forget about it. Well, yeah, but I don't think it really changed anybody's opinion or anything like that. Default Python thingy CPython, which actually translates to C. Yeah, it's like interpreted by C. Yeah. Same with like the JVM and things like that. Like most of the languages that they said were um, either originally written in C and C++, currently written in C and C++, or interpreted by C and C++. No C means no world. Yes. It's just too integrated now. Like Rust obviously wasn't. That was written in OCaml, and now it's self-hosted. But a lot of the library is still called 2C code. It's like it's kind of hard to escape C entirely. No C, no C. I like that. Okay. Get rid of this. Alright, that works. And then right. So I did have it at one point. Let me go in here. It's actually need a test. It doesn't work now. I did have print float in the assembly. Oh shoot! I just called to the send letter. Yeah, right here. Let's see. So we have print new line. Yeah, I want I have that print. Okay. Yeah. It's kind of a lot of stuff. Like I might not that bad though. Yeah, so I'll probably try to re-implement this at some point in Kano script, right? So we can call to it and then print floats, because in that way it'll be easier to visualize some things. Because then we can print integers, we can print floats, we can print strings, things like that. So that's pretty cool. And then eventually I'll make one function where it's like, I don't know, don't want it to be like the printf. I need to implement periodic arguments for that. I'm not sure. Don't think there's many languages I could use for many of my work apart from C and assembly. Maybe unsafe Rust with inline assembly, but that's kind of the same. Yeah. Yeah, that's the thing. Like, there's not really a lot of languages that could replace C in a lot of cases. Yeah. Yeah, for sure. Mm, what is, I think there's like, what's it called? It's like Zig or something, which is kind of trying to go for that. Niche job, yeah. Somebody asked me to describe Rust in simple terms. I say it is the language where the official way of fixing certain errors is making the code in a different way. Niche job. It sounds so. Is it like some sort of embedded system thing or something like that? Because that's usually what I think of with C and assembly. Does it still work though? That is interesting. Some passive. Look, no it does not work. Okay, interesting. Research CPU vulnerabilities. Oh, okay, that is pretty cool. Ooh, that's pretty cool. So it's like think of Spectre and Meltdown. Ooh, does that still work? Let's do this. Print in TMD. Yeah. Okay, so it looks like most of them don't work. As I thought, does these buttons still work? I don't think. That one actually won't work. How about hello world? That still works. Should push stir that native right. Yeah, that should still work. I think. Kind of brought you into the whole thing. Nice. Sounds like an interesting job, actually. Probably not a whole lot of jobs like that, though, I would imagine. As you say, niche. Bachelor thesis on Spectre on Apple devices. That's cool. Mm. So in the research group, now doing your PhD. Nice, nice. Mm. Come again, give some more performance. Disable what? Each time. Let me make a loop, perhaps. Actually, I'm gonna move it up here. And then I move on. Okay. To do I equals 100 plus 1, and let's try that. Not print anything. Okay. That's not good. Oh, because it started at 12. I am stupid. Okay. Alright, so that does actually work. So I could do 100. Iterate by 100 time. And do long is less than 5. Maybe I'll get iterated by 50 this time. Alright, nice. So that works. Mitigation. Yeah. The patches. Less than or equal to 5. Okay, nice. That works. Alright. Glad that that works. Depends a lot on the CPU and the code you are running. How long is this going to take for? That's actually pretty fast. Alright. Okay. So let's try, yeah. Okay, nice. General overhead of the mutations isn't that bad. I guess between 0 and 10% depending on what you do. Okay. Hard to pinpoint. That makes sense. Someone on Reddit says they get better results in a graphical benchmarks with the mitigations off. Should I believe them? Well, that's kind of like that's a case by case thing, right? Like I could go and post something on Reddit right now that says that, having not tested it. That doesn't mean you should believe me, right? Okay. It's not called bleed, it's called get. We have a chance to destroy. Okay. What do I get the type for? What do I use that? Hang on. Huh. Why do I do that? I don't think yeah, okay. That is interesting. Doesn't mean anything. Why did I do that? Don't remember what it was for. At all. Okay. Let me actually look at the assembly. Probably some things I could add some things. Like let's see. So then actually that's probably fine. Let me open it again because it looks better. Yeah, I just want comments for each instruction that we have. So maybe maybe not for that. Actually, it's probably fine. I think these are all right. Yeah, like just give me an idea of what instructions are being executed for what compiles to what. Older Intel CPUs are generally more impacted by mitigations. Well, that makes sense. I'm gonna do this as well. And here. But the impact on graphics benchmarks should be limited. Don't really have numbers on it. Yeah, it just depends on how CPU graphic is, really, right? i5 2310, nice. I have an i5 2400. Not too different. Close numbers. Okay. Here's sucks too. I mean, I don't know. I don't really do a lot of intensive things with it, other than like compiling software. So I don't know. But yeah, it's like I don't think it's too different from the 2310. So like yeah, it's the what does it say there? It says here, right? Yeah, 2400. So what's the you say 2310? Yeah. So it is a higher clock speed, nowadays. Yeah. But I'm pretty sure they are pretty similar. It's like slightly different. What I'm gonna do is actually change this to a switch statement here, here, but in this, yes. Four core, four thread, yeah, same thing. So when to find whether it impacts you is to disable them and see if it makes a difference. Runtime mitigation makes sense. When to disable that? Okay. Alright, so basically I need to take these ones. So here, switch to data. Case of that. Do this stuff. So, what's the best way to do this? This could be an array of characters. You iterate over it. If it equals anything, set it equal to that type. I'm gonna do that. I don't know, I'll just have this or something. Alright, what else? Equal okay. Equal and I think we have this one. And this. Do I use those actually? So should I? Okay. I guess we do use these ones. We have comma and new line. This is called token type. Oh, okay. Let's just redo this. Okay. And this one is open bracket. It's close bracket. There we go. Okay, so I think that gets rid of most of these. Ta-da. One second. Okay, yeah, so I can get rid of these now. I have these covered. Now we need to go into the default case, and then it basically just becomes the switch thing. Every process could read all your memory, including kernel memory, and it is not really hard to do, only until CPUs are affected by the bad original meltdown. Does that mean they can semi-Robux? Okay. There we go. So that gets, then I can move the rest of the if stuff up here. Ta-da. Okay, yeah, so this can be moved, and all of these up here as well. Imagine a 10-year-old afraid of that. I would be afraid of that as well. I spent many hours to get these robots. What's from the browser? Say you're watching a malicious ad while buying Robux. Gift card or whatever. This method could leak the code from the memory. Did you really play it when you were young? No, I haven't really played Roblox. I played Minecraft. Minecraft is good. Okay, there's 15 I need too. Okay, and some tiles. Need to onion them. There we go. Moomoo.io. I've not heard of that. Picture meltdown are not that bad for end users. Moomoo. Oh, this looks like I used to play this with my brother and cousins. It was like survive.io. It looks similar to that. Alright, what is this? Oh, it needs to be a single. It's 205. I have to go in about 5 minutes, so I will just finish up quickly. Great. Right, token that. Did I not add that? Oh, you know what? I did not do that. There we go. That works. Yeah, I just forgot to change that one. Gateway Student 5. Also learned English there. Nice. Still play it sometimes. Alright. That's pretty cool. Yeah, the one that I used to play. That's what it's called. Which looks like this. It might be the same developers or something. Let's see. No, that's not it. Yeah, I don't know what happened to it. It might be this. Yeah, this. This was it. Like that. There's no sound, but that. My games are W. For sure, for sure. Okay, there it goes. That's at least a little better. Again, it could be an array, though, I believe. That is fine. Make that. Well, actually, I need to get rid of the comment. Did I get rid of that? I did not. Oops, that one. Alright. Move if block into search statement in lens. Alright, so I will push that. Then I do have to go. Played that too. Survive.io was so cool. Nice. Yeah, it was fun. It was fun. Yeah, I played with my cousins. Okay, yeah, so I think that is probably going to be about it, as I do have to go now. So, I should probably update the README here and add some more stuff because it's very outdated. What's this? Yeah, like this. This doesn't. This example. Yeah, but that's about it. So I believe good to go. All right, yeah. So thank you guys for watching and thank you for the discussion as well. It's been fun. See you guys next time.